my name is Yvonne Ichisan. My matrix number is DE190014. Today, our group are going to present about Lab 4 Latching Relay. Now, I will explain about the program 5.1. This is the program that we require to build. This is the X0, the normally open contact. Then X1 is the push button stop, normally close contact. And the relay, this is a network 2 relay and also the output. Now I will run it. First, we turn on the X0. The output will also turn on. When I turn off the X0, the output will also on. This is because when the program starts running, push button X1 is activated. Since it is a normally close contact, it will also always conduct current until it is activated. So either the push button X0 is on or off, the output will remain since the M1 contact acts as a memory latch in the system. Now I will try with the X1. We set as force on. We turn on X1. So we try X0. When we turn on, the output will not affect since it is always off. When we turn off the X0, it will also become no effect to the output. So the output will become turned off. This is because when X1, it is a normally close contact. Since it is turned on, it will become like an open switch. The current will not flow through. X1 is acts as the reset of the system. Since it will in reset condition, any input will not bother to the output already.
Hi, my name is Farah binti Hassan, CE180071. So, for Lab 4 Latching Relay, so I will explain for experiment 5.2, which is a sensor is placed outside yellow line that encloses the robot to provide safety caution to the user. If the sensor detects someone crossing the yellow line, the robot will automatically stop its operation and the siren will be on until a reset button is pressed. Design your program using Latching Relay. So I will design this program using ISP soft. So this is designed for experiment 5.2 that I will build previous. So for network 1, we need to create the push button and add that relay 2 and relay 1. So network 1 related to network 2, which is we use again for relay 1, and the output Y1 we assume as robot. So for network 3, we use a sensor which is we need to stop the siren. So for network 4, we use the relay 2 again, and the output Y2 we assume as a siren. So to run the program, we need to compile first. We can then go to the PLC, transfer, and wait to download, transfer. Okay, then we need to click the online mode to run the program. Okay, so the M2 and X3 turn to green, so we need to run. Okay, to run the robot, we need to activate the X1. Okay, when we activate the X1, the robot will start working as shown at output in Y1. So when the sensor detect someone across the line, so the sensor will activate and the Y1 will not working. So the M2 will the siren will on activate. So when the sensor detect normal pupil within the yellow line area, the sensor X2 will deactivate. So To turn off the siren, we need to deactivate the X-ray, and then automatically the push button will activate again, and the robot will start working again. So that's all for me. Thank you.
This is the program 5.3, which is an automatic home direct system. It have sensor 1 X1 and X2. X1 will detect either the car move into the home, and X2 will also detect it. First we run it. When X1 is turned on, means the car is enter. The garage door will open Y1. So the car will move until it detect until the X2 sensor to detect it. The car is inside, so it will turn on. When sensor 2 detect the car, it will turn on. Since it is a normally close contact, when it turn on, the current cannot go through, so the garage door will open. It means that the car is fully parked inside, so the garage door will auto close. That's all for me. Thank you.
Good day everyone, my name is Cheng Wei Lun, and now I will show the demonstration about the question 6 in the lab sheet. So the question is about, in a factory, one conveyor is used for apple packaging. At first, operator will be placed an empty box, then start button is pressed. The apple conveyor start to move. Apple conveyor consisting of row of apple which is arranged accordingly. Sensor 1 will detect the presence of apple. The apple will fall into the box one by one. After 10 apples has been counted by SE1, which is the sensor 1, apple conveyor will stop and it is ready to be picked up by the operator. To build this system, use Latching Relay to design your program. So let's see our program. Okay, so this is the design of the Apple conveyor. So in the network 1 is the latching relay to turn on the conveyor. So this is the push button. When this network is on, the relay will turn on the conveyor, which is Y0. And the M1 is to stop the conveyor when there is 10 apples scanned by the sensor. So in network 3 is the stop trigger for the conveyor, which is when the counter in network 4 count until 10 apple, it will trigger the stop trigger contact here, and it will stop the conveyor in network 2, which is here the output Y0. And in network 4 is the counter network. So in this counter, the enable, which is the input, is connect with the sensor, and this contact only will turn on when the conveyor is turned on, which means if this one is not turned on, which means the conveyor is not on, is not working. Whenever the sensor sends something, the counter will not respond to it. So this is as a tree and as an enable of the sensor. Okay, so after it count 10 times, it will trigger C0, which is the stop trigger. And then lastly here, network 5 is to reset the counter. So the condition to reset the counter is when this is activated, the counter will reset again when the operator push again the push button here. Whenever the conveyor is on, the reset trigger will not activated. When the conveyor is off, this reset trigger will on again and reset our counter. Let's continue on the simulation of this program. To turn on this program, we just only turn on this push button X0. Okay, so to make sure this program will work with only one push button, after we turn on this button, we have to turn it off. Later, I will explain why it is important to turn off this button. So now let's continue to the conveyor part. After the push button has been turned on, this relay, this latch rest relay will keep the conveyor on. And since this conveyor Y0 is connected with this contact here, and this contact is act as the enable for the sensor. If this one, the condition to turn this on is when the conveyor is on. If the conveyor is off, of course, this contact will remain off. And when this contact is remain off, whatever the sensor scan, the counter will not respond to it. That's why it's as the enable for the counter and the sensor. So next, we will stimulate by manually turning on and off this contact sensor X2 to simulate the sensor has scanned the apple 10 times. So now I will turn on and off it for 10 times. Okay, so now it's 10 times already. We can see that here is automatically reset to 0, and at the same time the conveyor is off because there is already 10 times, so the operator will take away the boxes with full of 10 apples. And you can notice here why this trigger will automatically reset is because of here. This contact also connected with this conveyor Y0. And the condition to activate this contact is when the conveyor is stopped, which means it's on condition, and this one will be turned on and reset the counter. So this is the reason why we have to turn off the push button after we turn on the system. If the push button remain on, the system will automatically reset, and the operator is not enough time to take away the box with 10 apples, and the next 10 apples will be start filling into the box with 10 apple already. So this is the reason this is very important that we have to turn off this button. And because of this system will work when with only one button. So continue to the next 10 apples. The operator only need to turn on this contact again. Turn on this contact again, and the conveyor will be start moving, and the reset trigger here will be off, and the system will be run as usual. The system will be run as usual. Okay, that's all for me. Thank you.